Preparation of phenol through decarboxylation. This is today's lesson. In this lesson, we are going to learn sodaline, definition, composition and function of sodaline, and then preparation reactions. So let's begin. Firstly, sodaline. Definition of sodaline, composition of sodaline and function of sodaline. Let's look at the matter. Sodaline. Two words, soda and lime. Definition of sodaline is a mixture of sodium hydroxide and calcium oxide. Sodium hydroxide, which is known as caustic soda, and calcium oxide, which is known as quicklime. So, definition of sodaline is a mixture of caustic soda and quicklime is known as sodaline. Now let's see composition of sodaline. Sodaline contains sodium hydroxide is around only 3%. Quicklime is around 75%. This is a big difference. Caustic soda is only 3%, but quicklime is 75%. What is the reason behind this? We will try to learn. Then water. This is around 20%. Caustic potash, this is around 0.1%. Other chemicals is around 2%. This is the composition of sodaline, in which sodium hydroxide 3%, calcium oxide 75%, water around 20%, caustic potash around 0.1% and other chemicals around 2%. Now let's see function of sodaline. Sodaline basically acts as carbon dioxide absorbent. It's a kind of carbon dioxide absorbing chemical. Now let's see how it absorbs carbon dioxide. Carbon dioxide gas is absorbed by water first to form carbonic acid. Then this carbonic acid reacts with caustic soda, sodium hydroxide, to form sodium bicarbonate. Then this sodium bicarbonate reacts with quicklime, calcium oxide, to form calcium carbonate, and again sodium hydroxide is formed. That is, here sodium hydroxide undergoes recycling. This sodium hydroxide again participates in absorbing carbon dioxide through these reactions. So in this reaction, sodium hydroxide can be said catalyst. That is, sodium hydroxide catalyzes the reaction. As sodium hydroxide is produced through reactions again, that is why sodium hydroxide is only 3%, because recycling of sodium hydroxide occurs, but no recycling for quicklime, calcium oxide. That is why this is 75%. So this is the reason behind a high difference in ratio of sodium hydroxide and calcium oxide. That is, Sodaline, mixture of sodium hydroxide and calcium oxide, absorbs carbon dioxide gas. So simply it acts as carbon dioxide absorbing chemical. It is carbon dioxide absorbent. This is all about Sodaline. Let's move on to the next point. Now the point is preparation reactions of phenol through decarboxylation. For this, a compound sodium salicylate is taken. Let's write formula of sodium salicylate. This is phenol at ortho position carboxyl group. Now this is salicylic acid. When this acidic hydrogen is replaced by sodium metal, then it's a kind of salt. Name is sodium salicylate. When sodium salicylate is mixed with soda lime, which is written in this way: caustic soda, quicklime, and the mixture is heated, then sodium salicylate converts to this compound, sodium phenoxide or sodium phenolate, and in this case COO, that is carbon dioxide, is released from the reaction. Release of carbon dioxide is known as decarboxylation. This carbon dioxide is absorbed by soda lime. That has been showed in previous point. Now step 2. This sodium phenoxide is hydrolyzed in presence of hydrochloric acid. Then this compound is formed. ONA converts to OH plus sodium chloride is formed as byproduct. The desired product, phenol, is obtained. In this way, through decarboxylation from sodium salicylate, phenol can be produced. This is all about preparation of phenol through decarboxylation. Here, decarboxylation occurs. Carbon dioxide is absorbed by soda lime. Here, soda lime acts as carbon dioxide absorbent. This is all about preparation of phenol through decarboxylation in presence of soda lime. No more today. Thank you very much.